You ever make a decision that just feels right, even if you can't logically explain why? Well, it turns out your brain might be playing by a completely different set of rules than you think. So let's dive into a powerful and, frankly, pretty strange new theory about how our minds really work. For decades, psychologists have been totally stumped by certain quirks in human thinking. It's like we have these, well, logical glitches. We consistently make choices that, according to classical logic and probability, are just completely irrational. But are they? All right, let's try a classic thought experiment together. I want you to picture Linda. She's 31, single, outspoken, and super bright. In college, she was all about social justice. Now, which of these two statements feels more probable to you? A, Linda is a bank teller, or B, Linda is a bank teller and is active in the feminist movement. Just go with your gut on this one. If you chose B, hey, you're in good company. The vast majority of people do. But here's the twist. It's the statistically impossible answer. I mean, think about it for a second. The group of all bank tellers has to be bigger than the group of feminist bank tellers, right? Because that second group is just a smaller slice of the first one. This famous puzzle has a name. It's called the conjunction fallacy, and it completely breaks a basic rule of classical probability, the kind of stuff you can draw with Venn diagrams. A single category just can't be less probable than that same category combined with something else. So what on earth is going on here? And it's not just the Linda problem, not by a long shot. There's a whole family of these puzzles. Like in games, people will often choose to cooperate only when they're uncertain about what their opponent will do, which makes no logical sense. And get this, in opinion polls, just flipping the order of the questions can dramatically change the answers people give. So all these persistent puzzles, they were practically screaming that our old models of thought were missing something big. And this led a few pioneering researchers to a really radical idea. What if the human mind doesn't operate on classical logic, but on the mathematics of quantum mechanics? And you know, what's so wild is that this idea isn't entirely new. Way back, Niels Bohr, one of the actual founders of quantum theory, he had a hunch that its principles could apply way beyond physics, maybe even to human knowledge itself. Okay, hold on. Let's pause for a super important clarification. This is the big one. We are not saying the brain is a quantum computer. This isn't about tiny particles firing between your neurons. The theory of quantum cognition is just proposing that the mathematical framework of quantum probability is an incredibly good tool for modeling how we make decisions. Think of it as a powerful analogy, not a physical description of the brain. So how does this actually work? Well, it requires a pretty big shift in how we think about, well, thinking. It's about moving away from these rigid logical sets and toward the idea of fluid, shifting mental states. Okay, so let's break this down. Classical probability, like with those Venn diagrams, it assumes everything exists in one big, stable reality. But quantum probability, it's based on geometry, on vector spaces, where context and order are everything. Answering question A and then question B is not the same as answering B, then A. This right here is a total game changer. And this brings us to the single most important idea in all of this. The word is incompatibility. In quantum terms, two questions are incompatible if asking the first one fundamentally changes your mental state. It alters the very perspective you use to answer the second one. The act of measuring your opinion isn't passive, it's active. It actually helps construct your reality. Okay, stick with me. Here's the intuition behind it. Before I asked you about Linda, your opinion was just a cloud of potential, a superposition of all the possibilities. When I asked, is she a feminist, that question acted like a beam of light, a projection, forcing you to take a perspective. Your answer then collapses that cloud into a definite state. But here's the key. You are now in a new mental state. So asking the next question, is she a bank teller, projects from this new altered perspective. And boom, this is why the illogical thing happens. That sequence of projections, first feminist, then bank teller, can actually land you on an answer that's more probable than if you just asked about bank teller from your original neutral state. The first question literally changes the geometry of the problem. And here's what's so amazing about this framework. It doesn't just solve the Linda problem. It gives us a single, elegant explanation for a whole range of these cognitive puzzles that, before, seemed totally unrelated. There's a core quantum principle called interference. It's this idea that different possibilities can either cancel each other out or amplify each other. And this one concept can explain all of these different phenomena. The Linda problem, why people cooperate more when they're uncertain, those weird question order effects in polls, even why we think a goldfish is a better example of a pet fish than just a pet or a fish. It all seems to stem from the same underlying quantum-like logic. Now, check out this real-world example. This is wild. A Gallup poll asked people if they thought Clinton and Gore were honest. When the Clinton question came first, 50% of people said yes, he was honest. But when the Gore question came first, that number for Clinton jumped up to 57%. Just asking about Gore first completely changed the context for the Clinton question. That is incompatibility in action. But here's where this goes from just a cool story to actual hard science. Quantum probability theory, or QPT, doesn't just describe these effects. It makes a precise, testable prediction. There's a formula, it's called the QQ equality, that puts a mathematical limit on exactly how much our answers can shift based on question order. And here is the absolute kicker. Researchers went back and tested this QQ equality against the data from 70 different national surveys. And time again, the results held up. This isn't just a clever idea, it's a model with real predictive power that's been proven again and again. So, what does this all mean for how we see ourselves? It really forces us to step back and reconsider what we even mean by the word rationality. You know, for a long time, there have basically been two main camps. The classical view says our minds should follow strict, rigid rules of logic. The other view, heuristics and biases, basically says we just have a messy toolbox of mental shortcuts. Quantum cognition offers this compelling middle ground, a formal, rule-based system, but one with much more flexible, context-dependent rules. So the ultimate takeaway here is pretty profound. Quantum cognition suggests that our so-called logical errors, or biases, they aren't actually errors at all. When we're faced with fuzzy, ambiguous information and incompatible questions, these glitches are the perfectly logical outcomes of a quantum probabilistic system. Our brains aren't broken. They're just not classical. And this leaves us with a fascinating final question to chew on. Are we fundamentally irrational creatures, full of bugs and glitches? Or have we just been judging our incredibly sophisticated, context-aware minds against the wrong rulebook this entire time?